All right, we're going to go over what we did today in class on Wednesday, October 7th. We did some matter practice as we have a matter quiz coming up on Friday. The first thing we talked about is what is going to be on that quiz. It is 8 questions and 28 points. It's over matter notes 1 and 2. So if you think back into your packet, matter notes 1 was all about that's 2. Matter notes 1 were all about matter and how to break it down, pure substances versus mixtures. The 2 types of pure substances are elements and compounds. In the mixtures, you had homogeneous and heterogeneous mixtures, and you will be able to see on the quiz, there will be a set of microscopic pictures that you need to be able to pick out if it's an element, compound, or mixture. You will probably want to know how to fill in a concept map like this. And like I said, there's going to be some pictures. And then you're also going to want to be able to do what we went over today. Cohort A is going to physically take the quiz in class, but cohort B, you guys at home, you need to take that quiz on Friday between 7:30 and then it will close at 1:30. I know that there was a lot of technical issues today, so hopefully everybody got to this to make up what you missed today. But today is very important, so make sure you watch. I didn't record the class because it was more of an interactive class. I had the popsicle sticks back. Everybody loves those. So I was making students talk and things like that. So we just didn't record. So what I want you guys to do is go back to the notes, Unit 2 matter notes. It's in your packet. We did half of it yesterday in the lecture, but then we did the other half today. So I would like a little bit of participation from you. So hopefully what we can do is I'm going to do a refresher. So all the matter, okay, is broken down into 2 types, pure substances and mixtures. Pure substances is just one type of thing. It's either an element, which is the basic building blocks of matter, and you can find them on the periodic table. You will see things like helium or nitrogen or carbon or oxygen or aluminum or iron, those types of things. Compounds are when you have more than one bonded together. Then if you have more than one type of mixture or more than one type of matter together, that's a mixture, but as long as they're not chemically joined. Then we had homogeneous and heterogeneous mixtures. Homogeneous look the same throughout, so you can't see the pieces and parts. And heterogeneous is where you can see the different parts of the mixture. So with that refresher, what I want you to do, if you have Unit 2 matter notes, Part 2, we went through and I gave them about 5 minutes to work, and I want you to go through each of these examples, and I want you to think and write, is it an element, a compound, a homogeneous mixture, or a heterogeneous mixture? Sugar, what is that? Coca-Cola, what is that? Carbon. So go through. I would like for you to pause the program and go ahead and go through and make sure that you can label each one of these as one of these. And you can use your notes if you would like. All right, hopefully you gave it a shot. Let's see how you did. All right, sugar, the first one, C6H12O6. What do you think that is? Good, that was a compound. Coca-Cola. What do you think of when you think of Coca-Cola? Do you think of just a brown liquid? Do you think of a liquid with maybe some fizz in it? Or do you think of it maybe with ice in it as a beverage? So first of all, Coca-Cola is not an element. It has other things in it, and it's not a compound. There's sugar, and there's coloring, and there's carbon dioxide, and there's a whole bunch of stuff in Coca-Cola. So it is a mixture. At this point, you would have to be able to show me that you understand what a mixture or what the difference is between the homo and heterogeneous mixtures. A homogeneous mixture would be as if you thought that it was just all brown and you couldn't see any pieces and parts. However, some students saw in their mind's eye the bubbles. And if you can see the bubbles, then that's a heterogeneous mixture. And if you have ice in your glass even more, it's like definitely a heterogeneous mixture. So when you're doing these, you have to be able to support yourself and prove that you understand the difference between homogeneous and heterogeneous mixtures. Okay. All right. So Coca-Cola, you could have chosen either one as long as you supported yourself. Carbon, not for debate. Carbon is an element. Awesome. How about the next one? Kool-Aid mix. What do you think? Kool-Aid mix depends on what you thought of in your head again. If you just saw red food coloring or a red Kool-Aid, you know that it's not an element, it's not a compound, it's a mixture. And if you just saw a bunch of red liquid, you probably thought it was a homogeneous mixture. But then some people said, well, what? You said Kool-Aid mix. So I saw powder. Did you see a sugar-free powder where there's no pieces and parts? Or did you see the sugar powder where you can see the crystals inside of it? So if you said it's a sugar-free powder, that's a homogeneous mixture. If you saw the different things like the powder with the flavoring and the sugar crystals and stuff like that, if you could see the pieces and parts, that would be heterogeneous. Okay, but again, it's not an element or a compound. It's one of these two mixtures. You'd have to support yourself. Tomatoes is another challenging one. Okay, tomatoes depends on what you see. So tomatoes are not an element. They're not a compound. They have lots of different things in them. And if you saw pieces and parts to the tomato, like the stem and the flesh and the seeds, you had a heterogeneous mixture. And if you just saw red, you would see a homogeneous mixture. Okay. We're going to save tap water and distilled water for the very end. Aluminum. We had all these things out here, manipulatives. Aluminum is an element, Al. Oh, and we're just giving up answers apparently. Boop, 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 boop. You see nothing. The next one was salt water. Salt water depends on how you're thinking of it as well. Do you see salt water that still has salt in the bottom, or do you see salt water that is completely dissolved? Either way, it is a mixture, and it depends on what you kind of see going on there. So if it was homogeneous, that's nice, evenly dispersed salt water. You can't see the salt. It might be heterogeneous, though, if there's extra salt at the bottom. NH3 is a compound. Okay, that's ammonium. Strawberry jam. We had a nice lively conversation about what's the difference between a jam and a jelly. Okay, if you were in a preserve, if you were thinking strawberry jam is just the red stuff, that's just red gelatinous stuff, that would be homogeneous. But heterogeneous would be if you saw seeds or things inside of it. So it is a mixture. Magnesium is an element. Then we got to distilled water and tap water. And I love to put these ones on the tests because they're good to kind of see if you really understand the difference between some of these things. We kind of talked about this the other day. In tap water, there is water, but there's also other things. And I asked the students, and some people said, hey, I know that they put fluoride in it to help with your teeth, that you might use chlorine to or iodine to clean it. You might have some rust or iron from the pipes. You might have minerals in it. There could be some vitamins in it. There's lots of different things that they pick up in the pipe systems. And if it's groundwater, even more things out of the ground. So tap water is actually a mixture. You want usually for your tap water to be a homogeneous mixture. If your tap water comes out heterogeneous, you might want to look at getting that fixed. But then distilled water is a very challenging one because distilled water is nothing but H2O in the glass. So distilled water is not a mixture. Distilled water is a compound or a pure substance. Okay, awesome. Very good. So hopefully you got those correct. Love the bells. Hopefully you got those correct. If you have any questions, please make sure you reach out to me, but do know that I like to put these on the quiz. Then we talked about remembering what physical and chemical changes were. And a physical change, you make nothing new. A couple of the common misconception ones are state changes and dissolving. Those are physical changes. Chemical changes are when you get something new. It happens at a molecular level and you really can't reverse it. Some example or some evidence of chemical changes is if you see a gas produced temperature change by itself, if something disappears, if a solid is formed, if you have a color change, or if there is an odor present, you're probably looking at a chemical change. So then what we did is I gave them another few minutes to try to answer, is each of these a chemical or a physical change? So I would pause the program, go through, just write CC or PC, what you think for if it's a chemical or physical change. All right, hopefully you went through. Frying a hamburger, you have a color change, you have a new odor produced, and some gas produced, things like that. So that is a chemical change. Dissolving lemonade mix. If it says dissolving, I know it seems like the lemonade mix disappears, but you can undo it and it is still lemonade mix. That is a physical change. Tearing a sheet of paper is a physical change. Ice melting is a state change. That is a physical change. Crushing an aspirin tablet, you're just changing the shape and size. That's a physical change. Baking a cake, though, you have new odor produced, color change, solid formed, gas produced. That is absolutely a chemical change, and you cannot undo it. Lighting a match is also a chemical change. You have heat produced, color change, smoke, odor, all of those things. And then cutting a carrot in half is a physical change as well. So hopefully you got all those correct. The last one that we did was quite challenging because this is brand new. What you want to think about is if you're given 1 or 10 something, pick something like pennies. If I've been given 1 penny versus 10 pennies, does it make the property change? So I'll do one example with you. Mass, is it intensive or extensive? Okay, intensive does not change with amount. So it would be the exact same thing if you had 1 penny versus 10 pennies. And extensive does change if I had 1 or 10. So the first one is mass. So if I had a scale and I put a penny on the scale and the penny said it was 2.5 grams. If I put 10 pennies on the scale, would that make the mass go up? Would it be weightier if I had more pennies? And the answer is yes. So if it will change because you have more, that means it is an extensive property. Okay, so I would ask you to pause the program and go ahead and see if you can. You can write I, N, and EX for these, but you want to try them on your own. Make sure you pause the program here and take a look and see if you can get these correct. All right, color. If you have 1 penny versus 10 pennies, good. That is intensive. Doesn't change. They're still copper colored. Odor. If you have 1 flower versus 10 flowers, does that change the smell of the flower? No, I would call that intensive. Flammability, it is either flammable or not, so I would call that intensive. Volume, though, is going to be something different. If you have 1 penny versus 10 pennies, do you have more space taken up? Absolutely. And if having more changes that property, then that means it is extensive. Density, we said, is a very challenging one. I like to put density on the quiz as well. It doesn't matter if you have a little bit of water or a lot of water. The density of water is always 1. So that is intensive. Weight is just like mass. The more you have of something, the more weight you would have. So that is extensive. Melting point. Doesn't matter how much water you have, it melts at 0 degrees Celsius and it boils at 100. So it doesn't matter. And then solubility, it's either soluble or it's not. So I would call that intensive as well. So again, the biggest thing you want to make sure you're getting ready for is you're getting ready for Friday's quiz. 8 questions, 28 points. Make sure you can do your participation points if you've come to one of the classes this week. If you've not, you need to reach out to me and see what we can do to get you caught up. But on Friday, you will have a quiz. It's open from 7:30 until 1:30. Thank you, guys.